So thank you so much for everyone for coming to here. Is it good? Okay, perfect. I have some of my students here that are international, so I'm gonna do the talk in English, and I hope you'll enjoy it. Let me introduce myself. My name is Barış Yüksel. I'm the founder and CTO of Schema Plus. Oops. I've been working at Schema Plus for the last year, and before that, I founded another company called Uppercase Brands. And before that, I worked at Google New York office for 8 years at various teams, and most recently Google Translate, where we built NMTs, neural machine translation models. And I was in the production team where we actually deployed these models and saw the blue score increase. You can reach me at this QR code. This is my LinkedIn profile. You can just add me there. Okay, so today what I would like to talk about is the future of LLMs, what we should expect to see in the upcoming years. Of course, nobody knows. LLMs changed a lot of things, and it's still changing everything in the industry, in the academia. We see examples everywhere. First of all, I would like to point out that nobody knows how LLMs work. We know the architecture, we know how to design them, we know how to make them better, but we don't know how it actually works. We have some theories about it, some empirical ideas, but none of the researchers, none of the architects actually understand it. So in order to understand the performance of an LLM, we actually need to do tests, just like we test human students or human people, human experts. So we ask questions, and then we get the answers, and we ask human experts to rate the question, the answer. And if you look at it, this is a graph. The blue is the score of ChatGPT 3 model. And the green is the ChatGPT 4. And these are just tests. They are AP tests, English, math, science, US government, and US history. So the way we look at the performance of an LLM is literally by testing it, the same way we test human beings. So in 2023, AI, LLMs, surpassed human performance on image classification, visual reasoning, and English understanding. So I want to show you this graph. So here you can see the human baseline, and these are all different tests that we give to these models and human beings. And at this point, as of 2022, 4 of these tests, the image classification, visual reasoning, and English understanding, LLMs do much better. So what are the things that they can't do much better? Competition level mathematics, visual common sense reasoning and planning, and also complex questions. These things they cannot do very well at the moment. But I have some news for you. Those are these 3 tests here. They're almost there. Maybe next year they'll surpass humans on that too. So, because these tests have been surpassed, the researchers started to have design new tests, complex tests. And one of them is MMU, which is Massive Multidiscipline Multimodal Understanding and Reasoning Test. Essentially, it's college 3rd tier and 4th tier questions. I want to show you the questions to you. So these are the questions now we ask to ChatGPT or ChatGPT-like models. These are really complex questions. Some of the university students would fail these questions. And as of this morning, I got this data this morning. This is MMU's benchmark. These benchmarks are all over the internet. They're updated daily. A lot of people are interested in these benchmarks. So if you look at it, the human expert is at around 89-90% accuracy, and Gemini Ultra, which is Google's most recent LLM model, is around 59-60% accuracy. That's pretty damn close, right? So what we could predict is sooner than later, LLMs will be replacing university students. Okay, so let's go to coding. I know a lot of you here are either computer science students or AI students, and I'm pretty sure you guys are interested in how well LLMs do in coding, because this is a danger for your career in a way. So there are three tests for coding. One of them is human eval. It's 164 coding problems comparable to simple coding interview questions. The other one is MBPP, mostly basic Python problems, 1,000 Python coding problems, entry level. And there is SWE-bench, which is about 2,200 complex coding problems for experts. Let me ask you, what do you think the accuracy is in these data sets? Really low? Okay. What? Above 90%. Yeah, okay. So here's the answer. For human eval, again, I screenshot this in the morning. The code generation on human eval, the agent coder, which is a GPT-4 version that is specifically trained for coding. It has 96% accuracy. So these are the 164 interview questions, junior software engineer interview questions. It solves pretty much every single one of them. On mostly basic Python problem set, agent coder has 92% accuracy. This is 1,000 questions, entry-level coder questions. So then, what we can say is LLMs can do basic coding really well at this point, 2023. However, in the SWE-bench, the SWE-bench, don't forget, this is the 2,200 coding questions that are actually complex problems. I don't have one here. The SWE agent plus GPT-4 does 12%. But up until then, it was Claude 3 Opus. It was doing about 4%. But you know what? This trend will continue. It is 12% this year. Next year, it's going to be 25%. And the next year after that, it's going to be 50%. And the year after that, it's going to be 90%. And at some point, coding is also going into LLMs. Just the way, basic tests, basic scholastic tests, how they do so well in those, they're going to do really well in coding as well. Okay, so let's look at how this whole flowering of new technologies in AI is affecting the GitHub ecosystem. So in 2011, there was only 845 AI projects on GitHub. But in 2023, there is 1.8 million projects. And that's just in 2023. The GitHub projects from 2022 increased 60% in terms of numbers. So that's the trend. That's what's happening. And I wanted to put a graph. So this is the graph of all AI-related projects on GitHub. And you can see how from 2022 to 2023, it increased so much. 1.8 million. Until then, in 2022, it was about 1.1 million. Okay. Okay, so one of the most important things to note is LLMs have come with a certain rule. The performance of LLMs is a predictable function of N, the number of parameters in the network, and D, the amount of text we train on. Essentially, what I'm telling you is if you want to have better performance, for example, in the coding example, right? In the SWE agent, they do 12% accuracy. If you want to make this 25% or even more, we just need to feed it more data and more parameters. If we can do this, we know that the performance is going to increase. This is an empirical graph of the performance versus model size in terms of flops. Flops meaning floating point operations. And floating point operations are a function of the number of parameters and the data set, the size of the data set. So what that tells you is, let me put it this way. There is a gold rush right now for data sets and for bigger GPUs, graphical processing units, which we train the LLMs on, and better GPUs. More performant, better GPUs. So another trend is if we estimate the performance by the data set and the parameter size, then it means that the models are going to get more expensive to train on. So OpenAI GPT-4 used about 78 million worth of compute to train. And Google's Gemini Ultra costs $191 million to train. And this is a lot of money. And this also tells you that if you want to compete in this space, you need to have a lot of resources. Not only you need to have the money, but you need to have the compute resources. And this means monopolization of AI, unfortunately. You know, the bigger it gets, only a few players can handle it, and mostly governments, actually. So just to give you a comparison, AlexNet was the first deep learning network. It was not the first deep learning network, but it was one of the most popular ones. University of Toronto trained it, and they did a lot of, there's a lot of papers on AlexNet. It was launched in 2012, and it's image recognition model. It used 470 petaflops, and a flop is, as I just said, is a floating point operation. And peta is, I think, 10 to the 15 zeros. And Gemini Ultra used 50 billion petaflops. So that's a huge increase in size, in dimensions of this operation. And imagine this, they want to do even better. So maybe we're talking about 50 billion today, and next year it's going to be 500 billion, and maybe even more, right? So I just want to show you, these are the y-axis is the flops. So AlexNet is on the left bottom, and Gemini Ultra is at the top. And you can see GPT-4 is also pretty close to Gemini Ultra. These are a bunch of training costs for different models. 191 million Gemini Ultra on the right-hand side. Facebook's Llama 2 is about $4 million. And GPT-4 is about $78 million, as we said. These are estimated, of course. Some of these numbers, the companies actually announce it, but for example, for GPT-4, it's just estimate. And of course, now comes the big money, right? The future of LLMs is monopolized big money, where the resources are. Sam Altman just last month was seeking $7 trillion for building an AI chip factory, and that's more than the federal budget of US. So this is a lot of money, a lot of resources, and the future of LLMs are going to be in the hands of just a few people. So now let's ask another interesting question, right? We can have as many parameters as we want, but what if we run out of data, right? There's only countable instances of data in the world. So we should ask this question: is it possible that one day we're going to run out of data? So actually, Epoch AI is a group of researchers. It's an organization. I took these numbers from them. They did some modeling, and according to their model, the high quality language data will be exhausted before 2026. So in 2 years' time, all the high quality data means books and newspapers and articles that are written by people who know what they're doing, experts essentially. So all of this data is going to be used by all the models. And that means the progress stops. Low quality data is people's blogs, comments, Reddit, comments on the Facebook posts, low quality data. That will be exhausted somewhere between 2030 and 2050. And we can say 2040, right? In 15 years. So that means that all that data we will collect and it will be fed into a model, and that's it. There's no more data in the world. Vision data, about the same time, okay? We have a lot more visual data, imagery and videos. So that will be exhausted somewhere before 2060. So then what happens? Well, we start using synthetic data. Essentially, we make up data. We use probably another large language model to produce random data, some text or some imagery. But what happens is, there are some papers on this. When you use synthetic data, after a few iterations of training, the answers become narrower. And they start losing accuracy and performance. So this is another issue. Are we going to run out of data? Yes, we will run out of data in everything at some point. What's going to happen then? Well, we'll train it on synthetic data. Well, if we train on synthetic data, what's going to happen to the performance? It's going to go down. So this is an issue. So these are the predictions that they have. You can see how the number of words, and then so they use two different methods based on compute and then extrapolation from trend. Trend is historical data. They just looked at historical data and then said, okay, like last year, if we consumed this much data, next year we're going to consume this much data. The compute is the available compute resources, because believe me, the companies that build LLMs use all the available compute resources. That's another bottleneck, the data and compute resources. So these are the predictions. Historical projection, low quality language stock 2032, high quality language stock 2024. So they're actually predicting maybe this year we're going to run out of that data. Okay, so just to give you an idea, when I say we're going to run out of data, they're estimating that the total number of words on the internet is 100 trillion. And the largest LLM model that we have today uses 9 trillion words, so 1/10 of it, okay? All right, it's not pressing. Ah, okay. Okay. So I also want to look at the environmental impact of having these large models, because no one really talks about it. The more compute power, the more compute resources, the more we train, it means that we're doing carbon emissions. So it has an environmental impact. And I just wanted to put that into a perspective for you. Facebook's Llama 2, 70 billion parameters, used 291 tons of carbon. And this is 291 times larger than a single traveler doing a round trip from New York to London. Okay? Essentially, it's a whole full Boeing 777. Boeing 777 takes about 300 people. So it's a full plane traveling between London and New York, just one round trip, is equivalent to training Facebook's Llama 2. And also, this is 60 times larger than the carbon emitted by an average Turkish person in 1 year. An average Turkish person gets about 4.5 tons of carbon. Of course, this is found by looking at the full industrial carbon emissions of Turkey divided by the population. On the other hand, GPT-3 did twice as much in terms of carbon emissions and 500 tons of carbon. GPT-4 is estimated to have done 20,000 tons, which means 100 Boeing 777s doing a round trip between New York and London. So it increases drastically, exponentially. These numbers may not look that big, but as we move forward and build bigger and better models, these carbon emissions is going to be a thing. So in 2023, there were more foundation models. Foundation models are the models that we all talk about: Llama 2, GPT-3, GPT-2, GPT-4, GPT 3.5. These are the models that are available to usage. Some of them are closed. For example, OpenAI's models are closed. We don't know how GPT 3.5 works or GPT 4 works. We don't know the parameters, essentially. But Meta's Llama 2 is open. It's open source. So the foundation models, there were about 150 launched in 2023. This is more than double of 2022 numbers. So it means this year we're going to probably get 300 new models. So more models to be launched. And another thing is, the great news is 65% of these were open source, as opposed to 44% in 2022 and 33% in 2021. So another trend in large language models is there are going to be more open source models coming to you. So take advantage of it. Or take my class, because we're building one in there. So my students are lucky. Okay, so I'm almost done with my slides, but I wanted to put this into perspective as well. So the future of large language models, as I said, will be in the hands of a select few. And if you look at the main players, US, China, European Union, and UK are the main players. These are the countries, and most of these are going to sponsor. The government is going to sponsor these companies. And this trend will continue. So in 2023, 61 of these models were from United States. That's more than half of it. And the rest was just distributed across China, EU, and UK. We should also talk about the implications of large language models in our political lives. The video editing models the video creation models and the image creation models, unfortunately make deepfakes super easy to create. And unfortunately, they're really hard to detect. As of now, I don't know what will happen in the future, but this is a big issue. It may not be an issue for you because maybe you won't believe when you see a deepfake, but it's a big issue for the general public. There is an online, I don't want to call it a hacker, but online politically active person made a pipeline just to prove how easy it is to disseminate disinformation. So political disinformation exists since the time of Rome, or since the time of Byzantium. So that's not news. But what is news is that now it's super easy and super scalable to do this on your own. So he built one AI model to continuously scrape the internet to find news articles to write counter articles to. So, for example, assume you're an animal rights activist, and you write nice things about animal rights. Imagine that this person trained this model to find these animal rights articles. Okay, so then he trained another model to write convincing counter articles, essentially arguing the points in these articles. Imagine that in our example, this model would write anti-animal rights articles, okay? And then he wrote another AI model to generate comments on these articles, which looks like real human beings, and it looks like real organic engagement, okay? And then another AI model, so there are 4 models here, to search Twitter for relevant tweets, for example, by animal activists, and post the generated counter article as a reply. So he did it on his own for only $400. So this is the pipeline that he created. The first model selects the content to counter. The second model creates the article. The third model creates the comments. And the fourth one finds the tweets to post this article to, and then posts the article. Governments do this nowadays. They have armies of Twitter people who actually do and post these things. But the fact that just one person can train 4 models and just do this at scale puts the situation into a very different ballgame. So we're going to see more of this coming in our way. We're going to live in an ocean of disinformation. Another thing about the political part of the LLMs is that researchers have found that the models are politically biased. So ChatGPT has a positive systematic bias towards US Democratic Party and also Labour Party in UK. And they found this by retraining a ChatGPT agent for Democratic talk and for Republican talk. And then they found out that there's positive correlation between regular ChatGPT answers and the retrained Democratic ChatGPT, and negative correlation between regular ChatGPT answers and Republican ChatGPT. So this is going to be an issue too. The answers that you get from ChatGPT are not regulated for political bias. So this will be another thing. And this is the correlation. The default ChatGPT is the y-axis, and the political ChatGPT is the x-axis, and the blues are the the Democratic answers, and the purples are the Republican answers. Well, that's the end of my talk. Thank you so much for making time to listen to me.